Right, we are going to explore the concept of elasticity and Young's modulus to work out how much a child's femur bone gets compressed when they come to land after a jump. So when they land, basically the weight of their body is going to act, and the reaction force from the ground that decelerates them is going to act through this femur bone, compressing it. So let's just sketch the setup. We have a femur bone which we're going to idealize as a cylinder, like this, with a dimension of 30 centimeters this way, and a radius of 1.43 centimeters. And that reaction force that brings the child to rest is a force of magnitude 4,500 newtons, which acts at either end of the cylinder. And we're going to assume that it acts uniformly over this cross-sectional area A here. So if we want to know how much the femur is compressed, then what we're really trying to find is the strain. So we want to find the strain, which is that compression divided by the overall length. So we know that our Young's modulus is given by the stress over the strain, and what that means is that our strain is therefore equal to our stress over the Young's modulus. So the stress we can work out as the force divided by our cross-sectional area. So it's going to be 4,500 over pi times the radius of that circle. It's just the area of a circle, pi times the radius, and I need to make sure I am in meters. So it's going to be 0.0143 squared, which if I just type that in my calculator, I will get a value of about 7 million. So 7.0047 times 10 to the 6 pascals. Then my strain, just from my equation up here, is just going to be given by stress over y over the Young's modulus, which will be 7.0047 times 10 to the 6 over my Young's modulus of 9 times 10 to the 9. Which is going to give me an overall result of about 7.783 times 10 to the negative 4, and there are no units on strain. So finally, we know that my strain is equal to my change in length over my overall length, which means my change in length is equal to L times the strain, and that will be 30 centimeters or 0.3 meters times that number, 7.783 times 10 to the negative 4, which gives me a change in length of about 2.3 times 10 to the negative 4 meters, or about 0.23 millimeters.